Assalamu alaikum warahmatullahi wabarakatuh. So, you are welcome to another edition of our online mathematics class. So today we are going to discuss quadratic equations 2. So under it, talk about sum and product of roots. Before we move on, remember last time I taught you how to derive the general quadratic formula from the general quadratic equation. So I will quickly go back to that. So let's consider the general equation of ax squared plus bx plus c equal to 0. So from this one, I think you can derive your quadratic formula using complete square method. How are you going to do it? I told you that time that whenever you want to do quadratic, you want to solve quadratic equation using complete square method, the coefficient of the quadratic variable here must be what? Must be 1. So that's why I divide everything to what? By a. So now look at this equation now. You see that I start the equation as equation a1 because I'm still going to use it. So note that one. So from here, when we divide through by a, what's the next thing? You move this one to this right, to the right side. Then after that, you look for a number that must be added to make this equation a what? A perfect square. How do we do that? I told you that coefficient of x given, you multiply it by 1/2, then you square it. That's a particular number that must be added to make it perfect square. So, which means that this one, to make this one a perfect square, you have b over a times 1/2, everything was square. You add it to this side, then you add it to what? To the right hand side also. Which will go to the left hand side and the right hand side, we are going to add it. So from there now, b over a times 1/2 is the same as b over 2a, right? So here I have x squared plus b over ax plus b over 2a, everything squared. I told you that just pick one from this x, pick one from this one also. So you put them in bracket, then square everything. Because when you expand this bracket, you are going to get this one back. Then this side you have b times b, that's b squared. Then 2a times 2a, you will have what? We have 4a squared. So from there, we have, for this side, we have our LCM to work before a squared. So a in 4a squared, you have 4a. Multiply it by this minus c, that is minus 4a. Then this one here, 1 times b squared, we have b squared here. I think that was clear. So we now move to this place. It's not what? X plus b over everything squared plus some minus. We are not put it here now. So we have b squared minus 4ac over what? Over 4a squared. Now, the next thing is we want to make this part as the subject of the relation, which means that we have to cancel this square. How do we do that? You take the square root of both sides. That is, we multiply this power by what? By 1/2. So doing that, this one, when it comes to this place, we have square root here. So we now have, whenever you take square root of a particular number, you put plus or minus here. So which means now we what? Plus or minus b squared minus 4ac over what? Over 4a squared. So from there, we have x plus b over 2a. Please take note of that. Over 2a. So we have x plus b over 2a equals. So we now have plus or minus square root of b squared minus 4ac. You know this one, 4a squared. Square root of 4a squared is what? Is 2a. So you have 2a. Are you getting it now? So look at this side now. Make x is equal to that formula. You now be what? X equals, it will now be what? Minus b over 2a plus or minus b squared minus 4ac. That one inside square root. Then over what? Over 2a. So what's our LCM for the 2? That is 2a. We have x equals minus b. So LCM plus or minus, we have b squared minus 4ac. Everything over what? Over 2a. Please, you see that this division sign, it covers everything. It's not that you now stop here. This is wrong. Are you getting it? So the division should cover everything like this. So that's the general what? Quadratic formula. The variable might not be x in some cases. It might be variable p, q, y, and so on. But this is not where I'm going. Look at this equation now. Now, let's continue. We want to now move on to what? Sum of roots and product of root. Sum of root and product of root. That's where we are going. We just do that one as a short bonus for you. Now, let's move on. Sum of root and product of root. Let's say, let alpha and beta be the root of a quadratic equation of the quadratic equation that is quadratic equation what? Ax squared plus bx plus c equals 0. Now, the next thing now is, since that we have assumed that this one, alpha and beta, they are the root of this quadratic equation, we now say, therefore, x equals alpha or x equals beta. So from here, when we say that x is equal to alpha, it means that our x minus alpha is equal to 0. You should know that, because once you take this one back, it's this same thing. Or we have x minus beta equals what? 0. So from here, we can now have x minus alpha into bracket x minus beta. Everything equals 0. So when you expand this bracket, what do you have? You have x squared, then minus x beta minus x alpha plus minus times minus is plus, so we have alpha beta equals 0. Now look at this one now. What is common? X is common here. So we have x squared minus, this minus is also common. Factorize that minus out. You now have beta plus alpha. Then that's x, don't forget it. Plus alpha beta equals 0. So which means that we can have x squared minus, you can change it, alpha plus beta bracket x plus alpha beta equals 0. So I call this one equation A2. Equation A2. You remember I told you about equation A1 earlier. Now let's now come back to this our equation A1. So this is our equation A1 now. You now want to compare the equation A1 and the equation A2. Now say compare. So compare the equation A1 and A2. So you want to equate the two equations. So when you do that, what's our equation A1? So our equation A1 is x squared plus b over ax plus c over a. So you want to equate equation A1 to equation A2, or you can say equate A1 to A2. So our equation A2, which is this, so is A1 is equal to A2. We have x squared minus alpha plus beta x, then plus alpha beta. You know everything equals 0. Now, what are we going to do? When you compare the two equations, you see that this one and this one will go, right? So this is the constant term of this equation. This is the constant term of this equation also. So from here now, this one has the variable x. This one also has what? The variable x. So which means we can now say that b a x equals minus alpha plus beta x also. This x will go. So from here we can now say our alpha plus beta equals this minus when it comes to this place. It's what? Minus b over a. And I'm happy to tell you that this formula is what we call sum of roots. Note it down. So that is sum of roots. Now, also, you will see that from that equation, we can also equate the constant term. So, and that one will be c over a equals what? Alpha beta. So, c over a. So, also, From the equation, we have C over A equals alpha beta. So therefore, alpha beta equals C over A. So that one we call it what? That is product of roots. Product of roots. I think that one is clear. So, in conclusion, someone can just say that the general quadratic equation is x squared minus sum of roots x plus product of roots, everything equals 0. Are you getting it now? Everything equals 0. So that's all. Let's solve some examples and you see how we apply these formulas. So example 1. Let me tell you something before I move on to the example. Please, some question they might not use alpha and beta. It's not essentially a mixture of alpha and beta. They can use any variables. So if the one I'm solving now, we don't use alpha and beta so that you get it. I want to use P and Q. Are you getting it? So it's not necessarily it is alpha and beta. It might be any variable. So the question is if P and Q are the roots of the equation, if P and Q are the roots of the equation 4x squared minus 2x plus 5 equals 0. So they say P and Q are the root of this equation. Are you getting it now? Therefore, we are to find comma A sum of roots B P Q. You have to find P Q. Then C, find P squared plus Q squared. D, you find then D, so D, find 1 over P plus 1 over Q. That is D. So we want to solve all those four. It is very simple. Just pay attention. Now, for the first one, solution. The equation is given as what? 4x squared minus 2x plus 5 equals 0. Just compare this equation to general quadratic equation ax squared plus bx plus c equals 0. You will see that our a is 4, then our b equals minus 2, our c is what? 5. And the first question is sum of roots. And I told you sum of roots for P and Q is the same thing as P plus Q. The question might be P plus Q, alpha plus beta. Once you see the additions, you know that that is sum of roots. So from here, our sum of roots is given as what? Minus B over A. Then what is our B? Minus 2. Our A is 4. So which is minus into bracket minus 2 over 4. So we have 2 over 4. So therefore, our sum of roots equals 1 over 2. The next one is PQ, and that one is product of roots. So PQ, which is given as C over A, that one is straightforward. What is our C? 5. Then our A is what? 4. So which means we have 5 over 4. Then the next one, which is P squared plus Q squared. So P squared plus Q squared. This one might just look technical, but it's simple. Now, you recall just recall that P plus Q everything squared is given as this. You recall that one. So, doing that, from that, someone can just conclude that P plus Q everything squared equals P squared, P times P squared, then plus, when you expand it, you get 2PQ plus what? Q squared. From there, it should now be P plus Q everything squared equals, you see that P plus Q squared, then plus 2PQ. And what are we going to find? We are going to find this. Abi? That's the two we need. So which means now be P plus Q everything squared. Move this one to this side. Minus 2PQ equals P squared plus Q squared. Now it is now what? Straightforward. Because we have already known the value of P plus Q and the value of 2P, the value of PQ. So which means that this P squared, therefore this P squared plus Q squared that we are going to find will be substituted with this P plus Q everything squared minus 2PQ. Are you getting it now? So which is what? Therefore our P squared plus Q squared equals, you know P plus Q already, also our P plus Q. We get 1 over 2, Abi? So which we have 1 over 2 everything squared minus 2. What is our PQ? Which is 5 over 4. So we have 5 over 4. So from there, this one will be 1 over 4 minus 10 over 4. What is the LCM? 4. So therefore, your P squared plus Q squared equals 1 minus 10. That is minus 9. Abi? So your answer is minus 9 over 4. I think you get that one. Then the last one, which is D, which is 1 over P plus 1 over Q. I mean, 1 over P plus 1 over Q. So, that one, when you find the LCM, you see that the LCM is what? PQ. So, the LCM is PQ. So, P in P, Q in Q, you see that you have Q plus P at denominator. I mean, so, this is the same thing as saying P plus Q over PQ. Are you getting this now? And you know your P plus Q. So therefore, our P plus 1 over Q will now give us, what is P plus Q? So our P plus Q is 1 over 2. Abi? It will now be 1 over 2 divided by, what is PQ? 5 over 4. Divided by 5 over 4, which will be 1 over 2. You know, when you change this one to multiplication, you also change the numerator and the denominator. It will now be 10, 4 over 5. This one here 1, this one here 2, which means the answer is 2 over 5. Hope you get that one. Now, because of our time, let's just stand it up like that. Hope it's clear. I will just give you something to do. You know, let's do it like this. On this same question, you know, I found like 4 questions under it. So just make sure you go and do this. That same question, please find this one for me. That is D. Just find this one. Help me find P minus Q, everything squared. Then F, find P raised to power 3 plus Q raised to power 3. What else should I give you? Then also you can help me with this. Or let's not be like that, because these two alone, if you can solve these two one alone, I get it. You are